Hello dear students. Today the topic that we are going to learn is about the pumping lemma for regular set. So before we start, we will learn what we will learn in this video is, first of all we'll try to learn what is a pumping lemma, what is a theorem behind it, okay? And then we will try to understand with an example. So as we can see, a pumping lemma is used to tell us whether a given set is regular or not. Okay. So if a set is given to us, I will first assume that it is a regular set, or any language if it is given. I'll assume that it is a language. Then I'll apply a particular theorem on it. And then with that I'll see if that stands true, then I can say it is a prove that the whatever assumptions I made is correct, and if it is not following as per the theorem or the rules, then I can say it is not a regular language. Okay, so let's go ahead. Okay, so what is a formal statement for pumping lemma? Let L be a regular set, then there exists a constant n such that if Z is any word in L, means given language may, if there is a word called as a Z, okay, such that the length of Z is at least n, means the length of Z is at least n, minimum n is the length, maximum anything. So if I say n is 5, the length of that word will be minimum 5 or more than that. Okay, then I can write that word or a string Z as this UVW. So I am just splitting it into some parts. Some part is called as U, some is called as V, and some is called as W. In such a way that the length of U and V should be less than or equal to N. Now what is the length of Z? Is minimum N. So UV can be at least N or less than that. Okay, it can be maximum N. So say for example, if your n is 5, then your u and v can be anything which is less than 5 or equal to 5. But here the length of w is not a constraint, but length of v, if you can see, length of v should be greater than 0. Means greater than 0 is at least 1, or it can be 2, 3, 4, 5 something. Yeah. So v should be at least a single character. 1 or more means at least a single character or more than that. Okay, so length of v should be greater than 0. So if these all conditions are satisfied, then we check something. Now what is the condition that we are checking over here is, that is for any I, for any, that matters a lot, yeah, for any I which is greater than equal to 0, that means I consider some I which varies from what value? It can be 0, 1, 2, 3 and so on. So your I can be 0 or more than that. Then what should stand, which condition should satisfy? U v raised to I w. That means v is repeated I times. So v can be repeated 0 times. That means we are just cancelling out. If I take v as 0 number of times, then I can say v is not just coming, it is just u and w. If I take v as 1 times, it can be u v w. If I take v as 2 times, it will be u v v w. If I take v 3 times, it will be u v v v w. I hope you are following me. This way we are just pumping v more number of times with respect to value of I. So whatever string I will take, whatever value of I should take, I am pumping v that many number of times. So all the strings that I am getting with this I, yeah, so all the string should follow the rules that are followed by this language. That means those all string should be part of the language, or should belong to this language L. Okay, so if this condition is satisfied, then my assumption is correct and the given string is a regular string, okay, or a regular language. So means v can be pumped as many times the resultant string should be a member of L. That means it should be a regular language. Okay, so now let's go ahead and understand with an example. So here is an example given to me. Decide whether the given language is regular or not. The question will ask me if a language is regular or not. And if I say yes or no, then I have to prove it. How can I prove it? With the use of pumping lemma. So, and prove that your answer is correct. That means I have to use a pumping lemma. So now what is the language that it is given to me? L is equal to a raised to n, b raised to n, where n is greater than equal to 1. This is the question given to me. So what I'm assuming, very first what I have to do is always I should be assuming that the given language is regular. So what I'm assuming, the given language is regular. That means L will be accepted by the finite state automata. In this, what will come? Finite state automata means your DFA, NFA, your Moore, Mealy, everything will come in the finite state automata. Yeah, that means if a regular language is there, then it can be accepted by all of us. So now what I should be doing? So by there is a n. So now what they are saying, using something there is some n which says that. So here I am just writing the theorem in some short lines. You can see in green color I have just written the theorem over the. So the pumping lemma for says that if there is a string, Z belongs to L, that means there is some string which belongs to given language, and this symbol indicates and length of Z is greater than equal to n. So there is some constant n that I am assuming. What is Z? Length of Z is minimum n. Minimum n and more than. So in that case, I can say Z is equal to UVW. I am representing my Z in terms of UVW, and then I should check that this condition should satisfy. That is, U V raised to IW should belong to L. So whatever value of I will take, all the strings should be the member of the given language. Yeah. So now I'll just solve this for the given example. So here I am solving it. So consider A raised to M, B raised to M. Okay, this is my, I'm just assuming some string where M ka value is greater than N. So obviously I can assure that Z is greater than equal to N here. This I can assure, because if M is greater than N, then Z is also greater than N. That means my condition is satisfying. Then I am writing my Z in terms of U, V, W. So now Z is actually A raised to M, B raised to M. So I am writing my Z here. So Z is some number of A's followed by some number of B's. That means M number of A's followed by M number of B's. So this is all together M numbers. Okay, then I am just making sure that U, V and W I have to write. So what they are saying for U, V, W, U, V can be less than N and they can be maximum N. So N is this complete string. So I am just taking something which is lesser than that. So to be on safer side, I am just taking it less than M. Okay, and that's why I am skipping a last A to be take it as a less than M, and other strings I'm just taking in U and V. So randomly I have given some string in U and randomly I have given some string in V. So some strings I have given in U, some I have given in V, and then more than half I'm just putting in W. Okay, so I hope you understood what we are doing here, and after that I'm just writing around something. Yeah, so what is that? U is having how many number of A? So I can say, okay, U is having some P number of A's, V is having some Q number of A's. Then what is W is having? W is having some number of A's. What is that? It can be R number of A's. And how many number of B's? You can see it is M number of B's, because as we can see here, M number of B's are taken. Yeah, so in all, if I write my string, I can say this P, Q and R all together makes M. That is U, V and W are taking some number of A's. Altogether they are M number of A's. So I can say my word W or the word Z is somewhat written as A raised to P followed by A raised to Q followed by A raised to R followed by B raised to M. Okay, now this is in terms of U, V and W. Here this is U, this is V and this is W. You have written your Z in terms of U, V, W following all the conditions. Now we are checking the condition. What is the condition? I. So u v raised to I w should stand for all the values of I which are greater than or equal to 0. So here this is u, this is v raised to I have written, and this is w. So now I am pumping this v for more number of times. So what is the value of I? I can take a 0, 1, 2, 3, whatever. Every value के लिए it should be the member of the given language. Okay. So now I'm just assuming some value. So if I is equal to 2, let's say I is equal to 2. That means what will happen? I will just write down u as it is. So u I have written as it is, a raised to p. I is v raised to I now. So now I is 2. That means this string v should be coming twice. That means a raised to q is coming twice here. You see? Because it is I is equal to 2. So it is pumping 2 times. Then a raised to r, b raised to m, I am just copying as it is. So a raised to r, b raised to m, I have just copied. Yeah. Now what is my string? The string is like this. Yeah. So now in this, can I say a raised to p plus q plus r is equal to m? No, it is more than m. That means the number of a's are more than number of b's. So I can easily say in this string the number of a's are more than number of b's, and for I is equal to 2, and okay, or more. If I take I value more than 2 also, this case is going to happen, because of which I can say that is a raised to p, a raised to q, and I is equal to 2 is not a belongs to the given language, because here I cannot say number of a's are equal to number of b's. Yeah, and that's why I can say the assumption that I made is wrong, and I can say thus given language L is not a regular. So I hope you understood this particular type of example. If you are more confused, you can please ask me in the comment box, and for more examples on the same, please see the description box below. Thank you for watching.